So we're really just continuing with section 1.1. So we're calling this 1.1 part 2, right? And the last time I talked to you, we talked about how we derived the distance formula from the Pythagorean theorem, right? Where we came up with how we got the whole a squared plus b squared equals c squared, and how that becomes the distance formula, which was distance equals x2 minus x1 squared plus y2 minus y1 squared. Do you remember all that? That's kind of where we left off. Where we're going to start with that is we're going to be using the distance formula to verify right triangles. So we are going to talk about verifying right triangles. It's a little bit of a pain because you have to use the distance formula multiple times. But what we're going to do is you're going to be given, and this will be in your homework problems, you'll have to show, you want to show that points, show that the points two, 1, 4, 0, and 5, 7 form a right triangle. Well, the way we do that is we know that if the length of a squared plus the length of b squared equals the length of c squared, we have a right triangle, right? So if I have a triangle, right? Doesn't matter what it looks like. With, say, a point 2, 1, a point 4, 0. Remember, this is not drawn to scale, right? I'm just throwing it out there. And a point 5, 7. Whatever my shortest side is, and my next shortest side should equal my longest side. So if we say, let's find the length of this side and the length of this side and the length of this side. And the way we do that is using these points in the distance formula, right? So if we call this side 1, side 2, and side 3. So if I want to find out the length of side 1, I'll call it distance 1. I'm going to use these 2 points, right? We can call this x1, y1, this x2, y2. As long as I am consistent, I can go, okay, well, what do I know? I've got x2 minus x1. So 5 minus 2 squared plus y2 minus y1. So 7 minus 1 squared. And I'm going to find out that length, right? And so that length is going to be, let's see, we've got 5 minus 2 is 3. When we square it, it's 9. Plus 7 minus 1 is 6. When we square it, it's 36. And so that is going to give me the square root of 45. I can leave it like that for right now, right? That's the length of this distance, though, right here. This distance is the square root of 45, right? D2, we're going to use these 2 points, right? This distance 2 between these 2 points, we're going to say, doesn't matter which one I call x1 or x2, right? As long as I'm consistent. If I'm going to make this x1, y1, this one has to be x2, y2. So I'm going to look and I'm going to go, well, 4 minus 2 squared plus 0 minus 1 squared. And when I look at that, I got 4 minus 2 is just 2. When I square it, it's 4. 0 minus 1 is negative 1, but when I square negative 1, it just becomes positive 1. So I wind up with the square root of 5, right? So we know that this distance now is the square root of 5.
Hi.
Hi. I am in class. It's okay. Shh. So we know this distance, right? So now we've got to find that third distance. So we're going to do the same thing. We've got 2 points. I can make this one my x2, y2, this one my x1, y1. And I could go 5 minus 4 squared plus 7 minus 0 squared. And when we solve that, we get 5 minus 4 is 1. And when we square that, that just becomes 1. Plus 7 minus 0 squared is 49, which gives me the square root of 50. Bye, you guys. Have a good weekend. So I'm left with these 3 distances, right? I have the square root of 5 plus the square root of 45 plus the square root of 50, right? And those are my distances. So if I add these together, if I add the squares of these, right, this would be my, say, A plus B plus C or equals C, right? If I have A squared plus B squared equals C squared, right? And if this is true, we have a right triangle. So if I have the square root of 5 squared plus the square root of my next smallest one, 45 squared, equals the square root of 50 squared, then we have a right triangle. Well, if I square a square root, I'm just left with what's underneath it. So the square root of 5 squared is just, life is hard being a lefty, man. I'm telling you, every time I hit the screen, something crazy happens. The square root, if I square a square root, I'm left with what's underneath. So that would be 5 plus 45 equals 50. And that is a true statement. So we do have a right triangle. I believe in your homework they're all right triangles. You just have to prove it, right? You just have to keep doing the distance formula. Is it a pain? Absolutely. But there's only one problem that requires you to do it. Okay? So you're not going to be doing it over and over and over again. I had a problem on here. I was going to have you guys do it, but it's a fairly time-consuming problem. Right? There's a lot of labor intensity in this. Do you get it? Do you guys know how to work the distance formula? Do you feel good about it? Hold on, please. Okay. For a long time? Just a little bit. Does anybody not understand how we showed that was a right triangle? I feel like it can all be a little discombobulated on the screen sometimes. So I just want to make sure you're all good. We're going to write in purple now because it'll make me happy. We need to be happy on a Friday afternoon, and if purple is what does it for me. Wait, don't move it anymore. Like that. Just take a picture. What we will be moving on to is the midpoint formula. Everything's really formulaic right now. It's just learning formulas. The thing about pre-calculus is we're doing algebra 2, really. We're reviewing a lot of algebra 2, but we're moving into trigonometry, which is how we'll spend the second half of the year. So you'll see a lot of triangle stuff because trigonometry is the math of triangles, hence the trig part. So what we're going to be talking about now is the midpoint formula. And the midpoint, let's see. Can I move it up a little bit now? Thank you. So when we're talking about the midpoint, we're talking about the midpoint of a line segment. So if I have a line, let's see if I can make it straight, right? There is a formula no matter where this line falls between 2 points, I can find the exact center of it. And it's a fairly simple concept, almost so simple that you would find it that it's almost too easy. You think it should be harder. So the midpoint of the middle of a line or the midpoint of a line segment. Gosh, man. That connects 2 points. Can be represented dang, man. I was so good at this last year writing on this thing, but it's like starting over. By the formula. Ultimately, what we're going to do is we would add x1 plus x2 and divide it by 2 for the x value. And then we would take y1 plus y2 and divide it by 2 for the y value of the point. It's as basic as you could possibly get, right? You add your 2 x values or you add your 2 y values. So say my point was 9, 3, and this point was -5, -3, right? I can make either of those x1, y1, or x2, y2, right? I could call this point x1, y1. Those both look like x's. And this one x2, y2. Doesn't matter. It's arbitrary, right? I could have made these x1, y1, and those x2, y2. But to find the middle of these 2 points, the dead center of these 2 points, all I would do is I would take x1, which is 9 plus -5 over 2 to get the x value. And then my y's, I would go 3 plus -3 over 2 to get my y value. 9 plus -5 is just 4 over 2. 3 plus -3 is 0 over 2. So our point, when we reduced it, would be 4 divided by 2, which is 2, and 0 divided by 2, which is just 0. So our dead center point between those 2 points on the line would be 2, 0. So it's pretty easy, right? Basic arithmetic. So I'm going to have you guys do a point. I want you to give this one a go. I want you to hold off hitting send, but you're going to put it into the chat box. You're going to do it with points. -2, 8. And 4, -10. I want you to find the midpoint. Once you found the midpoint, I want you to put it into the chat box, but do not hit send until I say so. I want everybody to hit at the same time. We're going to chat bomb. I don't even know what it is yet. I should probably work it out myself. That was actually really easy. Does everybody have the point yet? I just need a little nod. All right, put the point in the chat box. And then hit, did you get it, Jameson? Hit send. Only see 2.
Oh my gosh, I'm stupid.
I got the same thing as you. I got 1, -1.
Yeah. Oh, wait, yeah, because a negative divided by itself,
Yeah.
number divided by itself is 1, right?
Yeah,
Okay.
I got -1, -1. Let's look at the point.
Okay, I know it's stupid.
I know the people who are seeing it now are like, oh yeah, I see what I did, but we'll do it on here. If we make this x1, y1, x2, y2, I would have -2 plus 4 divided by 2, and I would have 8 plus -10 divided by 2, right? If I look at that, I go, well, -2 plus 4, that's that's +2 over 2, right? We'd be left with 2 over 2, which would give us just 1, right? Here, I've got 8 minus 10. That's -2 over 2. And when I reduce that, I am left with -1. So for those of you who got 2, 2, I understand how you got 2, 2, but do you see where it looks like you guys did the top part, but you forgot to do the dividing it by 2 part? Am I right? Is that what happened? Like you did the -2 plus 4 and the 8 minus 10. You got scammed. Well, that happens from time to time. I felt like I was the one who was scammed in that one. So you're going to have some midpoint problems. You're going to have some verify the right triangle problems, but you are also going to have 2 word problems. Your favorite. I know it's everybody's favorite kind of thing right there is the word problem. You guys always love that. Because the reason we do stuff like this is because it's really good to be able to find the distance of something. And the problem we're doing right here, we're going to talk about. I always like to take the words out of the word problem. So say you need to find the length of a pass on a football field, right? Say we've got a football thrown. From the 28-yard line. Oh, I can't make the letters anymore. The 28-yard line. Um, 40 yards away from the sideline. Right? Say we're always measuring from the same sideline. And it's caught at, where is it caught? I wrote it down. The 5-yard line. 28 yards from the sideline. What's that going to look like? Well, it's going to look like a little football field, right? We'll only draw part of the football field because I'm not drawing 100 yards. Oh, I like it when it does that for me. And we'll say this is the, let's see, where are we starting? We're starting at the 28-yard line. So we'll say this is the 30-yard line. This is the 20. This is the 10. That's goal. Clearly not drawn to scale. So it's being thrown from the 28-yard line. Somewhere around here, we'll call this 40 yards away from this sideline. So we can call this 40, right? Because my X value, this is 40 yards away. 28. It's just a point, right? 40, 28. This one, we're saying, is caught at the 5-yard line, 28 yards away. So we'll call this, are both of them 28? Oh, sorry, this was supposed to be 20. 20 yards. I can't read my own handwriting. So this one's going to be 20 and 5. If we want to know the difference, the distance on this, all we have to do is make these x1, y1, x2, y2, and then do the, yeah. Well, it won't do the lines for me. That's the problem. So now we just have points, right? We don't even have to deal with the words anymore. We know what the 2 points are. So all we have to do is do the distance formula on those points to find out the distance of the pass, right? I can go, okay, well, we've got 40 minus 20 squared plus 28 minus 5 squared. Looks like it's going to be a fairly big number. This becomes what? 40 minus 20 is 20 squared plus 23 squared. When we do the math on that, 20 squared is 400, I believe. 23 squared, I don't know what that is off the top of my head. It's 529. And when we add those together, we get 929, the square root of. And if you put that into a calculator, we wind up with a 30-yard pass. Here's the thing about word problems when you're dealing with math, right? Everything's going to be related to something we just did. So everything that you can get in a word problem on your homework is going to be find some points and either find the middle of them or find the distance between the two of them, right? Nothing else is going to come up. So you kind of at an advantage when you're dealing with those word problems because you know exactly what you need to pull out of it. You just need to get some kind of an image with it. There's only 2 word problems though in the assignment. There's only 9 problems altogether. Any questions on this? Any clarification that you need? No, Desiree's got it. She's on it. She's like, give me the assignment so I can move on because I'm ready. This is just going to be an extension of the last assignment. It's going to be in the same section, so it's going to start on page 8, just like the last one. You're going to do numbers 24 through 40, but you are only going to do the even problems. What's that? The whole thing is posted in PowerSchool. I'll post the assignment onto PowerSchool though as well. I'm also going to post this video, which I'm going to stop right now, so I don't have to look at me anymore.